Hi there, and welcome back to today's section. So in today's lesson, we are going to look at a practice question on business statistics. And we are going to look at two-part session where we are going to focus on the first 25 set of questions, which consists of the questions and the answers, where learners are supposed to respond to the right answers after solving each question. And the second part is going to be where there's going to be questions for 25 set, going to be questions where no options will be provided. However, learners will be required to provide their own answers. So if today's your first time, do well to like, share, and then subscribe to the channel. So let's get into it. Question 1. Out of 100 numbers, 20 were 4s, 40 were 5s, 30 were 6, and the remainder were 7. Find the arithmetic mean. So arithmetic mean, x bar is equal to summation of what? The x values divided by what? The number. So here we have 24. So we have what? 2 by what? 4. Then we have what? 40 by what? 5. And then we have 30 by 6. And the remainder, it says 7s be the remainder. So that means that for us to get a remainder, we subtract the summation of 20 plus 40 plus 30 from 100. And we're supposed to get what? 10. All right. So that will be the remainder. So 10 by what? 7. All divided by, so the total number here is what? 100. Okay, so what do you get in summary? So you're going to say that here, we are going to get here as 80 plus 200 plus 180, okay, plus 70, all divided by what? 100. So we're going to have here as what? 530 divided by what? 100. And you're supposed to get what? 5.3. So that's going to be what? Option what? B. So you just have to what? Shade option B, or you circulate something like that. Get it and you are good to go. So that is for option what? B. Question number 2. Statistics was introduced first by a professor, Godfred Akinwall, in the year. So look at the options. A 1770, B 1793, C 1834, and D 1890. So here the correct answer is what? 1770. That should be the right answer to this question. So 1770. So you just have to shade option A. Question number 3. Which of the following is not a phase of statistical investigation? A. Collection of data. B. Exploration of data. C. Presentation of data. And D. Classification of data. So under classification of data, when we're looking at classification of data, the process involves collection of data, presentation, and classification, but we don't have exploration of data. So the correct option is supposed to be what? Exploration of what? Data. As not part of the options that are supposed to what? Have. Question number 4. Dash is another name for inductive statistics. Dash is another name for inductive statistics. A. Inferential statistics. B. Decisive. D. Descriptive. And then D. Exploratory statistics. So inductive statistics means what? It's a study that we can use to make what? Conclusion based on what? A small part. So we call that as what? An inferential what? Statistics, making reference or making referral to what? A data, right? By using what? Some part of it to reach a conclusion about that. So we call it an inferential statistics. So let's take note of that. Question number 5. Which of the following variables is discrete? Which of the following variables is discrete? A. Length of rod. B. Time of journey. C. Number of oranges in a basket. And D. Masses of clothes. So the correct option for discrete data, they are data which are said to be countable. So looking at the options, the correct option is supposed to be what? Option what? C. The number of oranges in a basket should be the correct option. Question number 6. A parameter is a quantity calculated from the observation in A. Population, B. Sample, D. Distribution, C. Distribution, D. Experiment. So parameter, then we are making reference about a feature about what? The population. So the correct option is supposed to be what? Population. It's a distinct characteristic of what? The population. All right. Question 7. Measuring temperature can be most accurately classified under which level of measurement? which level of measurement? A, nominal level, B, ordinary level, C, interval level, and then D, rational level. So what should be the right option here? Drop your answer in the live chat session and let's see. So measuring temperature is supposed to be an interval level of what? Measurement. So let's take note of that. Now question number 8. Before that, we have given some preamble information on top. That the variable x is represented by the series 3, 1, 4, 5, 3, 3. Use the information provided to answer the question 8 to 10. To answer questions 8 to 10. So the first question, we are asked to find what? Summation x squared. So we have what? Summation. We have summation x squared. So this means that we're gonna have what? The square of what? The x value. That at the end of the day, we sum them what? Up. So we're gonna have here as what? 3 squared, okay, plus 1 squared, plus 4 squared, okay, plus 5 squared, plus 3 squared, another plus what? 3 squared. So we sum them up in that order. We'll have here as what? 9, have here as 1, have here 16, here 25, here 9, and then here 9. So in sum, you're supposed to get what? 69. Can cross check and let's see. So the correct answer is 69, and you have to select what? Option what? C. Simple. Question number 9. Find the value of summation. So we have what? Summation x or what? Squared. So here it means that we're supposed to have a summation of all the x values and then they will square it. So we're gonna have here as what? 3 plus 1 plus 4 plus 5 plus 3 plus another 3. So the total sum, and we square it. So the total sum is going to give me what? 19. So 19 squared supposed to get what? 361. You can confirm that with your calculator and let's see. So that is the correct answer, and you go and shade option what? A. 361. Question number 9. Find the median of the series. So we are asked to find the median of the series. So median of the series is going to tell us the middle value of what? The data. So we are going to arrange them in order of what? Magnitude. In ascending order of magnitude. So we'll have what? We'll have 1. Okay. 3. Another 3. Another 3. We have 4. And we have what? 5. Okay. So having the data being arranged in an order of magnitude, then for us to determine the median, we are looking at what? The middle what? Value. So realize that the numbers are what? 1, 2, 3, 4, 5, 6. It's odd. So that means that for me to locate my median value, supposed to be my mid value is supposed to be what? Half of what? My end position or the end value. So what do we get in position form? Supposed to get what? 1/2, 6. You're supposed to get what? Third position. So in locating my third position means that I will come from both what? The end. I'll start and at the end. So this is what I'm going to do. I'll have here as 1, 2, then 1 and 2. So that means that I have what? 3 data values at the middle in 2. So that means for me to get my median, I can say that my mid value should be equal to half of what? 3 plus what? 3. And that should give me what? 3. So that's my median value is what? 3. And that will give me option what? B. So let's take note of that. Now, moving to question number 11 to 16, we have been given a preamble on top here. So let's see how it goes. It said the number of days a group of factory workers were absent in 2021 is given as follows. So these are a number of days that you can see. The factory wants to create a group frequency distribution for this data. Use this information to answer questions 11 to what? 16. So that's what you have been told to do naturally. So let's see the first question 11 under this set. So question 11 is how many classes should the group frequency distribution ideally what have? So that means for us to determine the number of classes, we need to go through the process of what? Creating what? A group frequency distribution what? Table. So let's start. We start with what? The steps, right? So we'll have what? Our step 1 and 2 coming up. So I'll have what? My step 1 and what? 2. Okay, so step 1 says that first you have to locate what? The highest value and then the lowest what? Value. So looking at this set of data, the highest value is what? You can clearly see that the highest value here is what? 46, right? And the lowest value is supposed to be what? 0. You can cross check and see. So that will help us to get, the extremes of the data that we have in terms of the highest and lowest. So that means once we get our highest value to be 46, okay, and our lowest value to be equal to 0, then we can proceed to find what? Our range. So range then should be equal to the highest value minus what? The lowest value. So the highest value is what? 46, and the lowest value is what? 0. So in all, we're going to get what? 46 as a first part. So once we have our range, that is fine. But I think here you are told to find what? How many classes should the group frequency distribution ideally have? So just have to go straight by using what? The strategies rule of what? Finding what? The number of classes the group supposed to what? Have. And that is the third step, step 3. So we'll have what? Our step 3 here. So strategies rule XR is supposed to be equal to what? 1 plus what? 3.322 log n to the base of what? 10. So here we can clearly see that the numbers are what? Let's count. So we have what? 1 on the row. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. On the column we have 1, 2, 3. So that means in all we have what? 30 as our total what? Number of absentees by workers in 2021. So we can straight up do our substitution. So we have what? 1 plus what? 3.322 log 30 to the base of what? 10. So in summary, what do we get? You can clearly say that you have what? Our strategy rule to be equal to 5.907. You can confirm with your calculator. But in running it up or running to the nearest whole number, we can say we have what? 6. Mostly for strategy rule, you run it to the nearest whole. Okay, so 6.0. So that means that ideally supposed to have what? 6 what? Classes. Supposed to have what? 6 classes. And that will go for what? Option what? C. Shade option C, and you are good to go. Then question 12. What would the width of each of the class in the group frequency distribution be? So whenever we are talking about the width, we are actually looking at the class size. So the class size is the next step. So step 4. Number of class or the class size, something like that. So this is the number of classes that you have found as strategy rule. So class width or class size being step 4. Let's see. So class size, I'll shorten it, okay, or class width, the same thing, is equal to what? The range over the number of classes desired. Number of classes that you're supposed to have generally. And the range was given as what? Our range, we had our range to be what? Let me take it from here, 46. And then we had number of classes are ideally supposed to be what? 6. So what do we get? Let's use the decimal part, which was what? 5.907. And you're supposed to get what? Supposed to get 7.787 in 3 decimal places. But when it comes to the width of the class, we always round it up. So rounding it up means that if there is any decimal part after the whole number, then that whole number will turn to the next whole number. So if it is 7.789, once we have a decimal part, it becomes what? 8. We don't care whether the decimal part is very small or, something like that. So once it has a decimal, it converts to the next whole number. So here the next whole number is supposed to be what? 8. This is what we call a round up or rounding what? Up approach. So that's going to be the width or the class size for question 12. So here we're gonna have here as well 8. Then we are good to go. Then question number 13. What are the class limits for the second class? So we want to know the class limit. So that is the next step we want to deduce here. We want to know our class what? Our class limit being the class interval, something like that. So we can create some space here and see how we can go with that. So we'll have what our class interval or class or limit. So class limit. So ideally we're supposed to have what? Number of classes of what? 6 classes. So before we can do that of our class limit, we first have to identify the lowest data, and then once we know the lowest data, then we can consistently add what? The class size, so that we can get what? The class limit for the 6 classes we're supposed to have. So this is what we're going to do. The lowest value here we identify was supposed to what? Were what? 0, right? So that means our first class limit will have a limit of 0. Then we'll just have to have a difference of what? 8. So that means 0 to 7 will give me what? 8, being the class size. If you want to check, it's fine. So that means we're going to count the 0 as part of what? The countings for us to determine the class size. So 0, 1, 2, 3, 4, 5, 6, 7. When you count your hands like they're going to get what? 8. So that means 0 to 7 will be our first class. What? Limit or class interval. Then 8 to what? 8 to 15 will be the next class. Then we have 16 to 23 will be the next third class. Then we'll have 24 to 31 being the fourth class. Then we have for 32 to 39 being the fifth. And lastly, 40 to what? 47. You can check and see. All right, you will get the class size of what? 8. And this is how it's supposed to be. So once you have the class limit, what was question 13? We are asked to find what are the class limits for the second class. So the class limit for the second class will be what? That of what? 16 and what? 23. So we'll have what? 16 and 23 coming to town here. So we have 16 and 23 as option what? C. Okay. So let's take note of that. 16 and then 23 become the class. But we're told of what? The second class rather, sorry. So I was looking at the third class. So second class, then we are looking at it from here, 8 to what? 15 rather. I was looking at the third class. So that means 8 to 15 is supposed to be the right answer. No big deal. All right. Then question number 14. What is the upper class boundary of the fifth class? What is the upper class boundary of the fifth class? So we need to have what? Our boundaries also coming up. Okay. So that means we will have what? Before we even get into boundary, we will have what we call tally. Or better still, we can let go, but that will depend on the question though. We can create straight up frequency without even tally it. Can straight up go. Then we'll have what? A class what? Boundary. Just want to shorten it like CB. Okay. So let's see for the class boundary. So the common point between what? The various classes is what? 1. So we divide 1 by 2. So we subtract what? 7 from 8, or subtract 15 from 16, or 31 from 32. You're going to get 1, and divide 1 by 2. We're going to get 0.5. So we subtract 0.5 from the lower limit of any class, and then add 0.5 to the upper class limit of any class. But here the focus was on what? What is the upper class boundary of the fifth class? So the fifth class here is what? This. So for us to determine what? The boundary is supposed to be what? Straight up is supposed to have here as what? 31.5 to 39.5. You can build up the rest. So here you're gonna have what? Negative 0.5 to what? 7.5. Then here you're gonna have your 7.5 to what? 15.5. You're gonna have your what? 15.5 to 23.5. And here you're gonna have your what? 23.5 to what? 31.5. Then lastly, you have here as what? 39.5 to 47.5 as our class boundaries generally appear. But we are told of what? The fifth class. So the upper class boundary of the fifth class supposed to be what? 39.5. 39.5. And that will go for what? Option D. That will go for option what? D. Option B, rather. Option B. That's going to be for option B. So let's take note of that. Then question number 15. How many classes how many classes will have a frequency of what? 0. I read again. How many classes will have a frequency of 0? So that means we need to know our frequencies coming up here. So let's go back to the table so that we can determine the number of frequencies that will fall within this class limit that we have already provided here. So we go back. So first, we want to identify the frequency of 0 to what? 7. Frequency of 0 to 7. So 0 to 7, let's begin like this. So 0 to 7, we'll have what? 2 here. We'll have, so we are moving on row by row. So we'll have 1 as well. We have 0 here. We'll have 5. Then we'll have another 5 here. We'll have 7 here. 0. We'll have 4. We have 3. 4 here. Then we'll have 4 here. We'll have 6. We'll have 5 here. 3, 0, and then another 3 here. So we count it on the column by column so that we can see or know the frequency generally up there. So let's take note of that. So we have 1, okay, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have what? 16 coming up as what? The frequency for 0 to what? 7. So we have for 16. Then move to the next class, which is what? 8 to what? 15. So let's see for 8 to 15. Let's see for 8 to what? 15. So 8 to 15, let's see what we will have. So frequency that will fall within what? 8 to 15 as a class what? Limit. So let's go. So we'll have what? Let's see. So the same row by row approach that we are moving. 8 to 15, we'll have for the first 15 coming up here. Okay. Then we'll have what? 14. Then we'll have what again? 13. Then we'll have 15 here. We'll have 12. Then we'll have another 12 here. We'll have 13. We'll have 14. 13. I think that is all. So we count them on column by column basis. So we have 1, 2, 3, the blue ones, 4, 5, 6, 7, 8, 9. So it is what? 9, right? So we have what? 9 as our frequency for 8 to what? 15. So 9. Then continue. 16 to 23. Let's see what we have for 16 to 23. 16 to 23. Let's see what we have. So 16 to 23. Let's see what we have. So in between 16 and 23, what do we get? So we'll have 16 and 23 row by row. Okay. Then second row. Then the third row. So nothing for that. So we'll say that dash, or better still, you can write what? 0. Then 24 to 31. 24 to 31. Let's see what we have generally here. Row by row. Then the second row. Then the third row. So that one's also what? 0 or dash. So frequency of 0 here. Then 32 to 39. Let's see what we have. 32 to 39. So 32 to 39, we have what? We have 36. Okay. We will have 32. Okay. We will have another 32 here. Then what again? Another 32 there. So we count the red word. Paint. So we have 1, 2, 3, and then what? 4. Okay, so that means 32 to 39 is what? 4. So we have 4 here. And then 40 to 47, let's see what we have. So I think the only one left is what? Just what? The 46. So it's just going to be 1. So you just have a frequency of 1 for 40 to 47. Okay, so once you are through with that, then we go back to question 15. It said how many classes will have a frequency of 0? So that means that those classes having a frequency of 0 supposed to be what? 2. So we'll have what? We have here 16 to 23 and then 24 to what? 31, giving us a frequency of what? 0. Giving us a frequency of 0. So that means that the number of classes that will have what? A frequency of 0 is supposed to be what? 2. Which are 16 to 23 and then 24 to what? 31. So let's take note of that. Then move on to question number 16. What is the cumulative frequency of the fourth class? So that means we need to have what? Our cumulative frequency also coming up generally here. Okay, so let's see. So that means that here too, we can also determine our class size because we know that class size was what? 8. So that means for each class, we have what? The class size of 8 coming up. So I can do that as here as class size. Okay. So let's go back to our cumulative what? Frequency. So for cumulative frequency, we use a less than approach method. Okay. So the first supposed to be what? 16. Then the next one supposed to be what? 16 plus 9. So we add the previous frequency to the current one. So that's going to give me what? 25. Okay. So the third one, which is 0 added to the previous one, I'm going to get what? 20, say 25. 0. So 25 again. Then for me to get my current, which is 30 to 39, the cumulative frequency, 4 to 25, I'm going to get what? 29. And then lastly, 1 to what? 20, I'm going to get what? 30. For you to know that your cumulative frequency is right, the last figure is supposed to give you the total frequency. And it's supposed to be correct. So the total frequency here, summation F, right, supposed to be equal to what? 30. And that means our frequency was what? Right. So let's take note of that. So here and there equal. So going back to our question 16, what is the cumulative frequency of the fourth class? So the fourth class is at this range, which is what? 24 to 31 is our fourth what? Class. 24 to 31 is our fourth class. So our fourth class for cumulative frequency is supposed to have what? 25. So let's take note of that. So 25 is going to be the answer for option what? 16, 25. Then question 17. So we are through with question 11 to what? 16. So let's move on to question 17. 17. Scores of a group of students in a business statistics quiz is given as, so we have 16, 19, X, 15, 25, and 20. The mean score was found to be 20. What is the value of X? So we have unknown value for the score. So we need to what? Find that value. But we were given the mean of what? These scores. So let's see how we go. So that means that we can apply the mean approach. So we'll say that our mean X bar supposed to be what? Supposed to be a summation of what? Our X values divided by what? N. Because remember, this is an ungrouped data, so we have the mean to be calculated like this. So we know the mean to be what? 20, right? And that should be equal to the summation of what? 16 plus what? 19 plus X, okay, plus what? 15 plus 25 plus what? 20. So how many numbers do we have generally here? We have what? 6 numbers coming up. 6. So 6 means that here, for us to solve for x, we do our cross multiplication and we are good to go. So add the numbers 16, 19, 15, 25, and 20. So cross multiplication, 6 by 20 is supposed to get what? 120, okay? And that should give you what? The total summation of the number is supposed to give us 95 plus x. You can cross-check and let's see. So having this means that we'll have what x or 25, or we'll have something like this. 120 minus 95 to be equal to x, and we'll have 25 to be equal to what? X. So our x is equal to what? 25. So that will give us option what? A, 25. So let's take note of that. Question number 18. So we have a preamble for that as well too. Use the information to answer question 18 to 20. After sitting for an end of semester examination, a student scores 78, 58, and 63 in business, mathematics, communication skills, and French, respectively. The courses have been assigned the weights of 4, 2, and 3, respectively. So these are the weights of the courses generally given here. So question 18. What is the student weighted average score? What is the student weighted average score? So for us to get the student weighted average score, the weighted average score supposed to be what? The mean, which is what? Should be equal to what? The summation of what? The weight multiplying what? The scores divided by what? The weight. So what do we have here? So we have the scores to be what? 78. So 78 carries a weight of what? Or 4 goes as a weight, goes with a score of what? 78. Or 78 carries a weight of 4. And then plus 58 also carries a weight of 4, 2. And then we have 63 also carrying a weight of what? 3. All divided by the weight. So we have what? 4 plus 2 plus what? 3. 4 plus 2 plus 3. So what do we have? In sum, what do we have? We'll have what? Here as what? 3, 1, 2. Here as 1, 1, 6. Then here as what? 1, 8, 9. All divided by the total weight, which is what? 9. So in sum, we will have what? 6, 1, 7 divided by 9. You can compute that with your calculator and let's see if that's true. Supposed to get that. So at the end, we're going to have an answer of what? 68 in 2 decimal place. 68.56. 68.56 generally up here. And that's going to give you an option what? Option D. 68.56. So option D supposed to be the right answer for question 18. Now question 19. What is the difference between the student weighted average score and the student arithmetic mean score? So where do you know the student weighted average score? So summation of x, I say summation of x bar with a weight value of 68.56. But however, we don't know the arithmetic score, so we need to calculate the arithmetic score. So arithmetic score as the normal mean, okay, supposed to be equal to the summation of what? The x values divided by the number. So what do we get as the arithmetic score generally here? Let's see what we have. So the arithmetic score, we're going to compute what? Just the summation of the scores without the weight. So we have 78 plus what? 58 plus 63, all divided by the number where we're having what? The number is supposed to be what? 3. Okay, so what do we get? We'll have the total of what? As our arithmetic score to be equal to 199 divided by 3. And we'll have what? Here to be 66.33. So therefore, the difference between the weighted average score and the arithmetic score supposed to be what? So we'll have the weighted scores compared to that of what? The arithmetic score. And that should give us what? That should give us, so here we'll have what? Or let me bring it here. So here we'll have what? 68.56 minus 66.33. So suppose to have what? A figure of 2.23. You can compute that with your calculator and let's see you get the answer like that. So let's take note of that. So that's going to be what? Option what? Option A. Option A. So you have that coming up. Make sure to like the video if you are finding value out of this presentation. Thank you, and subscribe to the channel as well and share. Question number 20. Assuming the student takes an additional course which has been assigned a weight of 2, how much should the student score in additional course in order to obtain a weighted score of 70? I take it again. Assuming the student takes an additional course which has been assigned a weight of 2, how much should the student score in additional course in order to obtain a weighted score of 70? So that means the students are also being assigned with another or additional course, but here we don't know the mass, but we already know the weight. And we have been given what? The average for that additional course together with the 3 courses that he or she was reading already. So that means that we can say that still the weighted score, we can say that 70, we already have our formula on top. So we have 70 to be equal to the summation of what? The weighted values, okay, which were what? 4 by 78 plus what? Plus 2 by what? 58. Remember, multiplication is commutative. 2 by 58 or 58 by 2 is the same thing. So let's take note of that. Then plus 3 by what? 63. Okay, 63. Since we have an additional course with a weight of 2, but we don't know the mark, we use the x, say x, to represent what? The mark of the additional course. And then divide all by the total weight of what? 4 plus 2 plus 3 plus what? 2. So straight up, just have to do our cross multiplication and we are good to go. So we'll have here as what? 4 plus 2, we're going to get us 6 plus 3, we are getting 9 plus 2, we are getting 11. So we'll have what? 70 multiplying 11, and that should be equal to the summation of the values on top. So we have 312 here, 116 for the second one, and you have here as what? 189 plus what? 2x. Okay, so here we add or subtract from what? The multiplication of 70 by 11. So we're going to get here as what? 770. Okay, 770. And that should be equal to 617 plus what? 2x. So bringing it here, we will have what? 770 minus what? 617 to be equal to 2x. So we'll have here as what? The difference of 153 to be equal to 2x. Okay. So therefore, we can say that our x should be equal to what? 153 divided by 2, and we'll get x to be equal to 76.5. So that means the student needs to have a score of 76.5 in order to get an average of what? 70 together with the existing course. 76.5. So the correct answer here is supposed to be option what? B. 76.5. So let's take note of that. So that's for question number what? 21 there. So question 21. The mean annual salary paid to all employees in the company is $36,000. So the mean for all employees. So we have what? Employees, male and females up here, because employees are generally combination of the two, unless it is specific. But let's read. So the mean annual salary paid to male and female employees of the company is $34,000 and $40,000 respectively. So now we can clearly see why we have a mean of 36 for all the employees. So we'll have what? The mean, okay, which is equal to what? That of males and females to be equal to what? $36,000, okay. So that means that the mean for males supposed to be, we're told is what? $34,000. Then that of what? The mean for what? Females supposed to be what? $40,000 here. 40,000. So we are asked to determine the percentage of males and females employed by the company. Very simple. So we can clearly see that we don't know the total sum of what? The salary paid to what? Individual males and females. Okay. But we have been given their mean. So that means that if we know, or if we represent their number by variable, we can then determine what? Their sum. So let's say the total number of males and females in the company should be what? M, and that of what? F. So we'll say that our general mean, or the overall mean for males and females, supposed to be equal to the summation of what? The number of males multiplied by what? Their mean salary. That will give us the total sum of what? Salary that we pay to what? The males employees. So we'll have that coming up as what? 34,000 multiplying what? M. Then we'll say plus. Then we'll have what? The same thing for females, 36,000. Also multiplying what? F. Okay. So that will be the summation of the salaries, since you have represented their numbers by M and then F. And then divide all by their total number, and that will give us the total overall mean of 36,000. Okay. So here was 40 rather, not 36. So 40. So we have here as what? M plus what? F. So we can finally say that here we will have what? We will have here as what? Because we know here is 36,000. So we'll have here as 36,000 multiplying what? M plus F. And that should be equal to, here we will have what? 34,000 M plus 40,000 what? F. So you just have to do what we call grouping of like terms so that we can subtract. So we can clearly see that here we can expand. So you're going to get here as what? 36,000 M plus 36,000 F. And that should be equal to 34,000 M, okay, plus 40,000 F. So by grouping and comparing, okay, by grouping and comparing, when we compare 34,000 M against 36,000, we're going to get what? 2,000 M. So we'll have to 2,000 M to be equal to, here to, when you also compare that of 36,000 F to 40,000, we're going to get what? 4,000 F. So that should be 4,000 F here. So we'll have here as what? So let me write it well for you. 2,000 M should be equal to what? 4,000 what? F. So in that way, if I want to find the ratio of M to F, I can say that I will divide both sides by what? Divide both sides by 2,000 F. Divide both sides by 2,000 F. So that means I have 2,000 cancel this, and we'll have what? M over F to be equal to, so F cancel F. 2,000 can reduce 4,000 by what? 2. So 2 over what? 1. So in ratio form, we'll have M is to what? F to be equal to 2 is to what? 1. So that means in terms of ratio, males have what? 2, and then females have what? 1. So for us to determine the percentage of males and females employed by the company, we'll just have to convert the ratio to a percentage so that we can freely go. So we can say that here, males supposed to be equal to what? 2 over what? Total ratio of 3. Okay, multiplying 100. And we're supposed to get what? With the calculator, supposed to get 66.667%. Okay. And that of the females, you do the same thing. We will have, so let me try to clean this. So that of females too will have what? F to be equal to 1 over 3 multiplying 100. And we're supposed to get what? 33.33%. So that means that in summary, for the percentage of males and females employed by the company, supposed to be 66.67 and then 33.3. But here we're given in just one decimal place. So that means we can go for what? Option what? A. So option A will be the right answer to this particular question. So let's take note of that. Now question number 22. Which of the following is not a property of interval scale? So interval scale incorporates all the properties of what? The nominal scale and then ordinary scale, right? But when it comes to interval scale, you don't have what? the starting point. We don't have the starting point or the ending point. So we don't want to determine the starting point or ending point. So there is no 0 point to interval scale. Okay. So let's see the options. Data categories are scaled according to the amount of particular categories that they possess is true. The interval scale does not require 0 point. So here, yes. Does require, it does not, rather. It should be does not require. So if you say does require 0 point, that is not true. Then data categories are mutually exclusive. That is true. And then data categories have a logical order. So A, C, and D are correct, but it does not require a 0 point. So here, since it says it does require, that should be the answer to that. So let's take note of that. You shade nicely. You are good to go. Then, question 23. For a frequency distribution in statistics for 100 students, the arithmetic mean was found to be what? 50. Later, it was discovered that Mark 48 was misread as what? 84. Find the correct mean. So how do we go? Very simple to go. Here, we know the frequency to be what? Here, we know the frequency to be what? F to be what? 100. Alright, and we will know our summation f of x to be equal to, so we have summation f of x, or f of the mean, sorry, that will give us our summation f of x. So our summation f of x like supposed to be equal to what? The frequency multiplying what? The mean. And you're supposed to get what? 100 multiplying what? 50. So the wrong mean, which is 50, multiplying the frequency that we're having, you're supposed to have what? 5,000 up. So it is this total sum that we have what? One of the mass which is supposed to be 48 but was measured as what? 84. So what I want to do here is we need to find what? The correct what? The correct summation of f of x, which is f of x subscript c. So that should be equal to what? The wrong what sum, taking away that of what? The wrong mark that was included, and add the original mark, which is supposed to be 48, to be included. So what do we get in sum? You're supposed to have what? 4,964. So this is actually what? The correct what? Sum. So correct sum. Okay, so once you have the correct sum, then we can then proceed to find what? The correct mean there. So correct mean is supposed to be what? The correct sum of what? 4,964 divided by the frequency of what? 100. So what do we get? We're going to get what? 49.64. Very simple, and you are good to go. So the correct answer is supposed to be what? C. 49.64. 49.64, and you're good to go. Then question 24. The class limits for two successive classes are given as what? 22.5, 22.2 to 22.5, then 22.6 to 22.9. So what are the class boundary for the second class? So this is the second class that we are talking about here. So what will be the class boundary? So as usual, you just have to compare what? The upper class boundary of what? A previous class to the lower class boundary of the next class. So here we will have the upper class boundary of first class compared to what? The lower class boundary of second class. So 22.5 taken from 22.6 supposed to have what? 0.1. Okay. So 0.1, you divide 0.1 by what? 2. And you're supposed to get 0.05. So 0.05 become the common point that will mark the class limit. So for us to get the class boundary for the second class, we'll subtract what? 0.05 from 22.6, and we add 0.05 to what? 22.9. So subtracting is supposed to get what? 22 point what? Supposed to get 22.55 compared to that to what? 22.95. Simple, and you are good to go. And that should give you an option, that of what? C, option C. So let's take note of that. And question, the last set of question for the first part of our discussion, which is question 25, is a multimodal frequency distribution has more than 2. So let's see. We said the mode is the most occurring data. Mode is the most occurring what? Number of frequency in a set of data. Okay. So for us to have that, it means that multimodal frequency means we have what? More than what? two modal values coming up. Okay, so when you represent a data in the form of a normal distribution, you always see that always the mode will have what the highest what peak. So this is how it's going to be. You're gonna have something like this. Okay, it's going to be like a curve like this. Just follow it gradually. Like a normal distribution, you always have the mode to always divide or have the highest peak to divide the curve into two equal parts. So you will have this. Okay, you will have the peak, the first peak. So you have the first peak here as more like a maximum curve coming up here. So this is where the mode will be located, right? Always at the top or at the middle of what? The curve. So you have what? The mode, say first mode, second mode, and then what? Third mode. So always the mode will divide. In a normal distribution graph, the mode will divide the curve into equal parts. So the mode will always have the highest peak. So that means that when it comes to a multimodal frequency distribution, it has more than two what? Maxima. If you have studied a bit about quadratic curves, this is what a maximum curve. So having more than two maximum curves mean we can refer that as what? A maxima in a plural form. So to have more than two what? Maxima. So the correct answer is supposed to be what? Option C. So let's take note of that. And that brings us to the end of part 1 of our discussion on business statistics exams as a way to prepare you for the future examination that you may encounter. So thank you for watching this video. If it was really helpful to you, please do well to subscribe. Make sure to like the video, and most important, drop a comment in the section. That will help and that will encourage me for me to provide more helpful tutorials for you. And most importantly, share the video for others to also to benefit on this channel. So I'll see you in the part 2 where we continue from question 26 to what? 50. Bye bye.